Today I will explain you first unit of becc-102, that is mathematical methods for economics 1. So this is unit 1 belongs to block 1. So block 1, it is preliminaries. So here details I will write down on the screen. So if I select black, then it will be better. So now here it is becc-102, and that name of this course, it is mathematical methods for economics. Okay, this is one. This is the course, and block 1, it is preliminaries. Okay, so before going into detail, what are the things which we should know? Okay, so block 1 I explained, and then after this is unit 1. So here I'm going to write down, that is unit 1, and name of this unit, it is sets and sets operation. Okay, mistake this one. So this is operation. Okay, maybe a little bit here it is P. Okay, sets and set operation. Okay, write down in the white screen also. So again, because the black screen is not supporting right now, so it is sets and sets operation. I wanted to write on the black screen, but yet it is not supporting. It is again and again it is moving. Okay, sets operation, that is a heading. Okay, means by mistake I was pressing the button. So under this the first it is 1.1, that is the introduction. So that is 1.1, that is introduction of this unit. So what are different things are given here? So here in case of sets, so what are the practical application of sets and sets operation in economics? So those things are written in the book. Okay, so this is the base on which remaining things are going to be established. So that's why understanding the concept of sets and sets operation very important. Okay, so now then after next given, it is the concept of a set. So next 1.2 given, the concept of a set. Okay, that is the concept of a set. So what is set? So that is a well defined collection of objects of any kind. Okay, again here moved. Okay, let me find out. Okay, here it is, concept of set here. Now what is set? Here I can write down, it is let me select another color. Okay, black, it will be better. So what is set? Well defined collection of objects. So I can write down well defined collection of objects. Okay, any well defined collection of objects can be called as set. For example, books, people means a well defined collection of books or anything. It may come anything, just like a set of even numbers. So that is well defined. Okay, set of even numbers. So just like set of even numbers 2, 4, 6 and 8, 10. In the same way you can go on. So this is well defined, that what are different things are going to come on as under even numbers. Okay, we know each and everything about even numbers, so that's why you can say that the set or the collection of even numbers will form a set. In the same way, if in any class 10 or 20 students are there, so exactly if we know how many students are there and we can define them, then we can say that that will form a set. So now next here one more example given, just like food items, means your favorite food items. It may be possible that you like 2 or 3 foods, means your favorite foods may contain bread, rice, curd, only these 3 things. Okay, so here we can write down bread, that is my favorite, rice and curd. If only these 3 things are my favorite, then in that case you can say this is going to form a set. Okay, now next, given elements of a set. So now next heading I can write down, that is so for writing heading it is better if I use so 1 point, no, this is under this one only, so I can hear what it is, elements of a set. Okay, elements of a set. An object which belongs to or is a member of, okay, any object which belongs to a set will be known as the element or the member of a set. Okay, for example, here you can see, so first an object which belongs to or is a member in a set, so it is better if I write, So let me change the color. It is a little bit slow, but I think this is going to work. Okay, here you can write down an object which belongs to, maybe here I am starting to write by using digital pen, so that's why it may be possible that in the beginning some issue it may arise about handwriting, but I will try to overcome this problem. Which belongs, now you see an object which belongs to or is a member to or is a member of a set is said to be, so we can say is said to be the element or member of a, said to be the element or member of the set. Okay, I don't know why it is again and again changing. Okay, that's it. Okay, maybe possible that here I am moving, so that's why. Okay, I will try to not move this. Now next, given cardinality of set. Okay, next heading we can, now you say elements of set. Now here if this one, it is a set. Okay, so generally when we write elements of a set, then we use small curly bracket. Okay, curly bracket we write, and elements we write down inside curly bracket. So here just like 2, 2, 4, 6, these are elements of a set because these belong to the set. Okay, for example, I can give the name of the set as A, and sets are generally denoted by capital letter, so that's why here capital letter A I used for denoting this set. Next given, okay, now next first of all let me select colors to write down the heading. So next heading, it is cardinality of a set. Cardinality of a set. So what is this cardinality? The number of elements of a set is called cardinality. So what is this? So here number of elements in a set. Okay, whatever it is, the number of elements in the set, that is known as cardinality of a set. For example, if in any set 4 or 5 elements are there, then those numbers will be cardinality. For example, I'm writing here I'm writing a set A, and here I'm using A, E, I, O, U. So 5 elements are there. So cardinality. So when we represent cardinality, then we use these vertical columns. So here cardinality of set A we can write down 5, because 5 elements are there. 1, 2, 3, 4, 5. 5 elements are there, so that's why. So I already told sets are generally denoted by capital letters, and elements are generally denoted by small letters. Okay, small letters or numbers. And if any set belongs to, just like here you can see in this case A, E, I, O, U belongs to set A, so that we can write down in this form. Here A belongs to set A, so in this form we can write down. It means this element A belongs to small a belongs to set A. In the same way, E belongs to set A, and if any element doesn't belong to the set, then we write down doesn't belong. Just like here I can write down B doesn't belong to set A. This is the way by which we can represent that whether the element belongs to that particular set or not. Now, how to specify the set? Okay, how to specify the set? Okay, let me select black, it will be better. Black or blue, yes, blue. Then next given here specifying a set. How to specify a set? Now next here given specifying a set. How to specify? Okay, so some methods are given. So particularly 2 methods we use to specify any set. That I will show you here how you can specify. So the first method here given, roster or tabular method. So here I can write down roster or tabular method. This is the first one. And second given here, set builder or definite property method. So here I can write down second, set builder or definite property method. So what happens in set builder form and what happens in roster or tabular method? You see, in case of this roster form, we write down elements inside curly bracket, just like here I can write on A, E, I, O, U. Okay, so here this is in the form of roster tabular method, and the second one, this is roster or tabular method, and the second one, it is set builder or definite property. So what we do here, so how we represent this one, so we write set builder just like, for example, just like P is a set, okay, X, and here we write down here X, and then we use vertical line here, and then after we write on the property. So how we write on the property, you can see here, X is a product manufactured by the company R. Okay, so here what is X, just like here X is the product manufactured by company R. So what happened here, X, here the, you can say, property of the element is defined. So what is the property here? In this case, X, the property is that X is the product manufactured by company R. So whatever product manufactured by company R is X. So that's here we write the property of the element. So here X is denoting any element. So examples of set, so many different examples we can write. Okay, for example, so some examples are given. So examples of set given. So here just like N, some standard notation used for certain kind of set here given. So for example, N is used for the set of natural numbers. Okay, for example, here we can write 1, 2, 3, so on. What is this? Set of natural numbers. Okay, this is set of natural numbers. In the same way, other we can also use just like other standard notation for other set, it is for set of all integers. So integers, you know, positive means natural numbers and negative of natural numbers including 0. So here we can write down just like 0, then plus 1, then minus 1, plus 2, minus 2, and so on. So this is set of all integers. So what is this? Set of all integers. Okay, this is set of all integers. Okay, where it went, where we were here. Okay, now yes, here we were, set of all integers given. In the same way, we can also use just like Q, it is for set of all rational numbers, or it is set of real numbers. Okay, we can write down. And next point here given, next topic, that is empty set. So write down the heading, empty set. What is empty set? with no element. Sets having, we can write down sets having no element. Sets having no element are known as empty set, or you can say empty sets. Okay, for example, and it is denoted by, and here we can write down denoted by 5. So example, it may be like, you see, A is a set of, here we can write down x, and x, what is this? X belongs to n, means natural number, and condition given, and x is in between 2 and 3. We know there is no natural number in between 2 and 3. Okay, so that's why there is no element. You can see, natural number meaning 1 2 3 4 5 6 7 8, means in between 2 and 3 there is that it will become rational. It will become fraction. So that fraction, it doesn't come in natural number. Okay, so that's why there is no natural number in between 2 and 3. So that's why there is no element in this set. So that's why we can say this set, it is a type of empty set. And now next, here given equality of set. Next, here given equality of set. So in which case we will say that two sets are considered equal when each element of, now you can see here, if A equals just like 3 2 1, okay, and B equals 1 2 3, when each element of A belong to B and each element of B also belong to A, then in that case only we can say A and B are equal sets. Then in this case we can say A equals B, set A equals set B. Okay, and if C is another set, in that element is 3 2 4, then in that case set A will not be equals to set C. Okay, so that's about equality of sets. That's all about this subsection. In the next class I will explain another section of this unit, that is subset, supersets and power set.